Hello student, hope you are doing well. Today in this video we are going to discuss a wonderful topic of class 9th NCERT chapter. So let's discuss the chapter number 2, that is basically polynomial. So I hope you are aware about the polynomial. What is polynomial? So the chapter name is polynomial, and before going to know lot of things about this chapter, just revise something that is required in this chapter. So I hope you earlier studied lot of things like some algebraic expressions, like lot of algebraic expression you already studied about the numbers, the factorization of numbers, the factorization of algebraic expressions. So just revise. You already studied these kind of algebraic expressions, like if I have a expression x plus y square. So I hope you are aware this is the x square plus 2 times xy plus y square, and lot of more. If I talk about x minus y square, x minus y cube, so you know very well these kind of things you know already. Now we are going to understand what is polynomial. So polynomial is also a very simple topic. Just try to understand it. What is, firstly we will understand the meaning of this word polynomial. So just I'm going to factorize this word into two word. First is poly and second is nomial, right? As the name is poly means more, more, something is more, and nomial is terms. So in very easy language, if I can say, the polynomial is nothing but more expressions, more algebraic expressions. So in simple words, I can say that more algebraic expressions, algebraic expressions, algebraic expressions means, algebraic expression means you already studied these kind of algebraic expressions, some factorization. If I talk about the factorization of any number like 6, so you can just say that 2 into 3. So these kind of things, if I take any special type of algebraic expression that has two terms, the first one is constant. Like in this special type of algebraic expression, I'm going to take some variable. I need to define the polynomial, so I need variable. And second thing, I need constant, right? So generally we denote the variable by alphabetical small letters like x, y, z, t, and etc. Lot of things you can take. So I'm denoting a variable as a small letter alphabetical, and constant is like any number that is fixed. So for example, if I talk about the constant, so like 5, 6, 9, and etc. Right? So basically the variable denoted by a small variable of alphabetical variable, and constant is fixed. So if I can say that this is nothing but constant is fixed number, fixed number. If you can also give the answer, the constant is 100 is also the constant. Yeah. Now, in case of variable that is not fixed quantity, we can vary variable as any number. For example, if I say, like suppose I have a variable x, and x is taking the value of 1, 2, 3, 4, 5. Now my x is taking these kind of values. So I can easily say that this is the variable that is varying up to 5 from 1, right? So these kind of things I need. Now I need coefficient. So coefficient is nothing but this is the whatever quantities multiple with variable. So I need a coefficient. So in simple language or for understanding, I can say that this is multiple of what is multiple of variable, right? Might be constant, might be variable, whatever, right? So this is three terms I need to define a polynomial. Now let's define the polynomial. So what is polynomial? Polynomial is polynomial is a special type of algebraic expressions, algebraic expressions, right? Or I can write it is is denoted by px, qx, rx as you want. Just we are taking the alphabetical number and this bracket inside x, and x is taking inside the bracket, right? So I'm writing a example of polynomial, very simple example. Your I'm taking the px, this is my px. P of x is equal to x plus, sorry, the px is equal to x plus 1, right? This is very simple polynomial. So here this is my variable, this is my variable, and now you can also give the answer. What is this? This is variable or constant? This is nothing but constant because this is fixed. Because in this case, variable case, I can take any value of x. Suppose I'm take x is equal to 1. So I can take x is equal to 1 because x is varying, because x is variable. So if you take x is equal to 1 and put, then when you will put this is 1 because in place of x you are putting 1. So this is p of 1, and you need to change at x is equal to 1 at every place where the x is here. So this is 1 because this there is also present in x. So this is x plus 1. So this is the total addition is 2. So this is basically the idea of variable. Now the coefficient is what? The coefficient is, I already gave you the definition of coefficient. This is not a definition. This is just for idea for understanding multiple of variable. Like here in this case, what is the multiple of variable x? So just you can say that multiple of variable x is, because I can write this px, I'm taking again this px is equal to x into 1 plus 1. Yeah, can I write this? Can I write this? Yeah, I can write this because this is ultimately x plus 1. Same. So because I want to see what is the multiple of x. So this is the multiple of x. Multiple of x. Multiple of variable x is 1. So this is your basically coefficient. So if you will go through the definition, whatever is given in your book, that is might be changed or might be just similar. That should be similar, but basically the term might be different, right? Let's discuss some more interesting thing. I hope everything is clear to you till here. Now we are just giving some more time to understand about the variable. What is actually meaning the variable? Because this is very important. If you will understand the variables, then everything is clear to you, because this chapter is very easy chapter basically. So in earlier classes, if I connect variable with your earlier topic, whatever you studied, so let's suppose you studied the word a lot of finding the area of any shape like square, rectangle. So suppose I'm taking a rectangle, right? Suppose I'm taking a rectangle and I'm giving you the question. Just uh, I'm taking this rectangle. Okay, the rectangle is, suppose the length of the rectangle is 3 centimeters. Suppose I'm giving this 3 centimeter length. This is 3 centimeter, and this is 2 centimeters the width. Now, what is the area? The area is, or just uh, find the parameter first. Then we will work on the area. So parameter is the parameter is what? What is the parameter of this? Just 2 times length plus what? Width. This is the formula. So because my length is what? In this case, length is 3, width is 2. So just put the value in the formula. So this is 3 plus 2 is equal to, this is simple calculation, 3 plus 2, this is 5, and 5 into 2, this is 10. So in this case, your parameter is how? You calculated 10 or 10 centimeter. This is your parameter, right? Now suppose I'm taking suppose I'm taking this suppose I'm taking this uh, suppose I'm taking another rectangle but little bit bigger size, right? Suppose I'm taking this. Now what I'm taking the length is 4 centimeter, width is 3 centimeter. In the next case, what is happened here? Your L is now 3, sorry, this is 4 because we have taken the bigger rectangle, and B is 3. Now what is the parameter? Can you calculate this? What is the parameter? So again use the formula, this formula, use this same formula. This is 2L plus B. Now what you are putting at place of L is now 4, and B in place of V you are putting 3. So what is happen here? 2 times 4 plus 3, this is 2 times 7, and this is basic calculation, this is 14 centimeter. So your parameter P is 14 centimeter. Now what happened? Your parameter is changed. Yeah, there is minor change of 4. Just we calculated our parameter for this rectangle, this is 10 centimeter, and for this bigger rectangle my parameter is 14 centimeter. So here try to observe this formula. Parameter of the rectangle is equal to 2 times L plus B. So now what is happening here? Here you are taking different size of rectangle. You are changing the size of the rectangle, and its parameter is going to be changed. That means what? Your that side of the rectangle and the width of the rectangle is working as a variable. Yeah. What is this? Are they working variable or not? Yeah. So that is the thing I am going to convey you. Because if you're taking any other rectangle of more bigger size, then maybe your parameter is again, you will see some change of your next parameter for this rectangle also. So I hope the variable is going to define. I'm going to define the variable with properly. So everything is clear about the variable. Let's take a very simple example. Very simple. More simple example. More simple example. Suppose I'm taking now, in this case, I'm taking a square, right? Let's take a square. Let's take a square. Okay. Suppose I'm giving you side of this square is 2 centimeter. Can you find the parameter? What is the parameter? This is the parameter. I'm denoting it. Parameter P. Side is 2 centimeter. This is 2 centimeter. So what is the formula for the parameter 4 square? This is 4 times side. Side. So 4 times, what is the side? Side is 2. So your parameter is nothing but 8 centimeter. Yeah. So this is your parameter for this square. Now think about the other uh, square of little bit bigger size. Suppose in this case, I'm taking again very simple explanation. I'm taking very simple explanation. This is also very simple explanation as previous. Suppose this 4 centimeter side. Now what is the parameter? 4 times side. So now I'm going to put at place of side is 4 because my side is 4. Side for this square is 4. So my parameter is changed with 16. Right. So what is the change here? This is the 8 centimeter, my old parameter for this square. Now for this square, my parameter is 16. So can we say that the side is working as a variable? Exactly. Exactly. My side is working here as a variable. So the polynomial is nothing new for you. You already worked a lot for this kind of things. So if I take an polynomial, because as in previous, I can also form a polynomial with this example. This is my px and x is equal to 4 times x. This is your side of a square. That's it. This is also the polynomial because at here the side is x. So ultimately you can see, you can form lot of examples. Px is equal to 4x, example number 1, and example number 2. You can form qx is, this is x, qx is equal to 2 times x plus 2. This is also a polynomial. So what is the general form? The general form. General form means how my arbitrary polynomial is looking like. So suppose I am taking some constants. Suppose constant a naught, a1, a2, a3, and an. Suppose I am taking lot of constant. Constant means that is fixed. That is fixed. Fixed might be integer, might be real number, might be n, right? And variable x, variable x, and taking powers of x means x square, x cube, x to the power 4, and so on x to the power n. Now the polynomial is looking is, this is a naught plus a1x plus a2x square plus and so on plus a n x to the power n is equal to my px. This is the general form of a polynomial. So this is the general form of polynomial. Now you can see that if you change the value of a naught, a1, a2, a3, an, and you can change the variable also, you can get a different uh, representation of polynomial, right? So here your x is variable, this is your variable, and these a naught, a1, a2, and lot of ans, these are your constants, and you can see that these are the coefficient. Suppose I am taking the coefficient here a naught. So who is the a naught is a multiple of which number or which expression? So Ultimately, your a naught is what? A naught into 1. So this is the multiple of 1. A1 is what? A1 is multiple of x. Yes, multiple of x. So this is coefficient of variable x, right? Now, there is other concept also like degree of a polynomial, right? Zeros of polynomial. And also in this chapter, we study some factorization of complex algebraic expressions, right? So basically, we try to observe these kind of concept and we take the help of this chapter to solve, to factorize more complex expressions. We also use factor theorem in this chapter. This is very, very important theorem in this chapter, right? So we already uh, uh, we will cover this a lot of topics in this whole chapter. So this was the today's content. I am just going to summary of this chapter is topic summary of this all the expressions. So we already uh, discussed the polynomial motivation, right? You already studied these kind of algebraic expression. So this is the topic similar like this. Polynomial means poly, more terms, right? If any algebraic expression has more number of terms, you just can say that this is a polynomial, right? Suppose 5x, 9x, even 2. So this is the polynomial. For forming a polynomial, we need first variable, the second one is constant, and third is coefficient. So variable is that can vary. They can vary. So these kind of expressions are these kind of notations are for variable we are using. For constant, we are taking any number, zero point 0.5 and any number that is fixed number, right? Coefficient is multiple of variables, right? Now, polynomial is for understanding. This is the simple line for understanding polynomial. Polynomial is a special type of algebraic expression denoted by px, qx, rx, and any alphabetical number, alphabetical notation. You can denote a polynomial. So, for in the simple example, I have taken px is equal to x plus 1. So here, this is the variable and this is the constant, right? In the next page, we give you the motivation of variable, where the variable is coming or how we can connect is in our earlier knowledge with variables. This is a very, very simple term that is varying. If you are taking any size of any triangle, rectangle, square, circle, whatever you can, now you are varying the length, you are varying anything that can that work as a variable, right? So this was the session. I hope everything is clear to you. Thank you so much for watching this. Bye bye. Take care.